and I'm a developer advocate at IBM. With me today, I have Hashim Noor. He's a client technical specialist at IBM as well. And we also have Kamar with us today. She will be handling the chat. So if you have any questions, do post them in the chat below. And for our topic today, it's going to be a basic introduction to big data analysis and machine learning in Python with Spark. Now, before we get started, I would really appreciate if you all can sign up to IBM Cloud so that we can save up some time when we're on the hands-on session. And you can find all the resources in the button down below. I will show you where you can find that button. So just to give you an overview of the Crowdcast, on your top left corner, you will find the name of the webinar which is taking place today. And if you click on the I button over here, you will find more details about the information about the session. And you can follow us on IBM Developer over using the button over here. So every time we go live, you will be notified, and you can also view all the upcoming events. You can chat with everyone using the chat section on your right bottom, and you can ask a question using the Q&A. We also have polls down below, so please go ahead and answer those. Now for the workshop resources, you'll find the button saying workshop resources for this webinar, and you will find all the links in that GitHub repository, as well as the dataset that we will be using today. So you can all take this survey and give us your feedback on what you think the session was and how you think the session was, what you would like to see in the future, and if there's anything you would like to come on stage and discuss with us, you can let us know through the survey, and we'll get back to you then. So for the agenda today, we'll be talking about the big data, the 5 V's of big data, how big data is causing digital transformation, and what is data science, the subsets of AI, supervised and unsupervised machine learning. We will then move on to what is Apache Spark, the components of Apache Spark, and why you should be using Apache Spark. Then the features and some use cases, which will then be followed by Hashim presenting the use case, the hands-on session. So now to get started, I would like to start with the quote that is, "Data is the new oil. It is valuable, but if unrefined, it cannot really be used." And what I mean by that is 44 zettabytes was the estimated data in the world by the end of 2020. And this is only the data that is publicly available to us, and there is tons of data that we still don't have access to. And when we are talking about such huge amount of data or data sets, we call this big data. Now, big data refers to the dynamic, large, and disparate volumes of data being created by people, tools, and machines. It refers to data sets that are so massive, so quickly built, and so varied that they defy the traditional analysis methods, such as the ones that you might perform with relational database. Now, there are different definitions for big data, but there are certain elements that are common across all those different definitions, such as the velocity, the volume, variety, veracity, and value. These are the 5 V's of the big data. To talk about them in a bit more detail, velocity is the speed at which data accumulates. Data is being generated extremely fast and in a process that never stops. Near or real-time streaming, local, and cloud-based technologies can process information very quickly. And a volume is the scale of the data or the increase in the amount of data stored. Now, the drivers of volume are increase in data sources, higher resolution sensors, and scalable infrastructure. The variety is the diversity of the data. Structured data fits neatly into 2 rows and columns. Now, structured data is very similar to your Excel sheets where you have rows and columns. And it's even your relational databases are rows and columns.
Anam, we cannot. I think you're having some problems with your audio. Can you try refreshing, if possible? Anam, can you hear us? Uh, Anam, if you're speaking, we cannot hear you. All right, so it seems like Anam is having some problems on her end in terms of connectivity. But in the meantime, for all of you who have joined our session today, thank you so much. I hope you enjoy today's session and take away from it. While Anam connects back, please
Hashim,
use.
can you hear me?
Yes, we can hear you. All right, perfect.
Okay, let me just share my screen once again. I'm sorry, there are some issues with my internet, I guess. Um, okay. Can you see my screen?
Yeah.
Okay. Should I start from the beginning of from velocity or?
I think from volume, you can start from volume.
All right. So volume. Okay, so volume is the scale of the data or the increase in the amount of data, and the drivers of volume are increase in data sources. The drivers of volume are increase in data sources, higher resolution sensors, and scalable infrastructure. Now, moving on to variety, it is the diversity of the data. Structured data fits neatly into rows and columns, and so structured data is basically your normal data, which is structured in rows and columns. Databases that you have, they are structured data, and in relational databases. So basically, any SQLs that you have, data that you use is structured data. So unstructured data, on the other hand, is not organized in a predefined way, and this could include tweets, blog posts, pictures, numbers, and video. Now, variety also reflects that data comes from different sources like machines, people, and processes. Both this could be both internal and external to organizations. And the drivers are mobile technologies, social media, wearable technologies such as your watches, geotechnologies, video, and a lot more. Moving on to veracity, this is the quality and the origin of data and its conformity to facts and accuracy. Now, the attributes include consistency, completeness, integrity, and ambiguity. Now, drivers for veracity include cost and the need for traceability. With a large amount of data available, there is a debate that about the accuracy of the data in the digital age, and we have to make sure that the data we're using is the information we have is real and not false. So we need to take into account about of that. Now, value is our ability and need to turn data into value. Now, value isn't just profit. It may be medical or social benefits, as well as customer, employer, personal satisfaction. Now, the main reason that people invest time to understand big data is to derive value from it. So, how is big data driving digital transformation? Digital transformation is not just simply duplicating your existing processes into digital form. The in-depth analysis of how the business operates helps organizations discover how to improve their processes and operations and harness the benefits of integrating data science into their workflow. So, what is data science? It is the process and method for extracting knowledge and insights from large volumes of disparate data. It's an interdisciplinary field involving mathematics, statistical analysis, data visualization, machine learning, and a lot more. It's what makes it possible for us to see patterns, find meaning from large volumes of data, and use it to make decisions that drive business. Now, data science can use many of the AI techniques to derive insights from data. Now, moving on to AI. AI is, you can think of it as an umbrella term which refers to any system that mimics human behavior or intelligence, no matter how simple or complicated that behavior is. If you move a little deeper into it and go into the specifics of the different algorithms and statistical methods that are used by computers to make predictions and make intelligent decisions, all of this comes under machine learning. Now, lastly, if you dig a little deeper, you have deep learning, which refers to a technique in which a system uses neural networks which mimic the activities of a human brain in order to make intelligent decisions. So now coming to the different types of machine learning techniques within the field of machine learning, we have supervised and unsupervised. The difference between these two techniques is that in supervised learning, we have the algorithm learns on a labeled data set. What I mean by this is that using this approach, we have some or at least some understanding of what our output is going to look like. However, with unsupervised learning, the algorithm learns on an unlabeled data set, meaning you don't know what your output should look like. So the goal with unsupervised learning is to learn about the structure of data, look for patterns, trend, or even segmentation in our data set. Now, coming back to supervised learning, it can further be divided into classification and regression. Classification problem is basically one in which the output variable is categorical, such as it's a disease or no disease, head or tails, yellow or green. So it's basically the output is going to be absolute. The problem, so if you have the output where your output is going to be absolute, that problem will be a classification problem. With regression, your output value is going to be continuous. Let me give you an example. If we have a data set with details of property, with different kinds of real estate properties, example, location, area, number of rooms, price, etc. And if we were to use the data to determine what kind of a property it is, so if we were trying to determine if it's a villa, an apartment, or a studio apartment, now, since the output is going to be absolute, it would come under classification. But if we were to use the data to determine the prices of these properties, that would come under regression because price is a continuous variable. The price can be $100, $100,000, $100.1, or anything. So it can range, the value can range from different values, and hence it comes under regression. Now, with unsupervised learning, it can be broken down into three. Firstly, clustering. Clustering refers to the machine forming groups based on the behavior of the data. For example, if we have a data set of customer behaviors using clustering, familiar kind of customers will be grouped together. So this is what clustering is, as the name suggests. Now, with association, it refers to the rule-based machine learning to discover relations between variables. If you want to understand how two variables in your data set are related, you go for association. For example, determining the correlation between heart disease and smoking, a problem like that would come under association. Or for example, the example mentioned over here, find what clothes I often wear together. So you can provide a set of clothes and it's going to basically figure out which clothes you wear together. And it's going to give you an output according to that. Now, lastly, with the dimension reduction, it refers to methods of presenting data by its features. Something that can be used in the fashion industry is making the best output from the given clothes. So if you're given a set of clothes, which pair of clothes would go together, right? So it can be used in the fashion industry. Now, After all of this, moving on to Apache Spark. So, an introduction. Spark is an Apache project, it's an open source project, and it's advertised as lightning fast cluster computing. It has a thriving open source community and is one of the most active Apache projects at the moment. Now, Spark provides a faster and more general data processing platform. Spark lets you run programs up to 100 times faster in memory and 10 times faster on disk than Hadoop. So Apache Spark consists of 5 components. Let's look at them in a bit more detail. So the first one is Apache Spark Core. Spark Core is the underlying general execution engine for the Spark platform that all other functionality is built upon. And it provides in-memory computing and referencing datasets in external storage systems. The second is Spark SQL. Now, this is the Spark's module for working with structured data. And the structured data, again, it's your normal predefined data, which is already set in rows and columns. So the interfaces offered by Spark SQL provide Spark with more information about the structure of both the data and the computation being performed. Spark streaming, this component allows Spark to process real-time streaming data. The data can be ingested from many sources like Kafka, Flume, and HDFS. HDFS stands for Hadoop Distributed File System. Then the data can be processed using complex algorithms and pushed out to file systems, databases, and live dashboard. The next one we have is the machine learning library. Now this is equipped with a rich library known as Apache Spark is equipped with the rich library known as MLlib. Now this library contains a wide variety of machine learning algorithms, classification, regression, clustering, and collaborative filtering. It also includes other tools for constructing, evaluating, and tuning ML pipelines. So all these functionalities help Spark scale out across a cluster. Lastly, there is GraphX. Now, Spark also comes with a library to manipulate graph databases and perform computations called GraphX. Now, GraphX unifies the ETL process. ETL stands for extract, transform, and load process, and it also unifies, it helps with exploratory analysis and iterative graph computation with a single system. Now, a common question could be, why do I need Spark and why can I not continue with Pandas? So Python, just being a scripting language, it has Python exposes several programming paradigms like array-oriented programming, object-oriented programming, asynchronous programming, and many others. And one of the paradigm that is of particular interest for aspiring big data professionals is functional programming. Now, the core idea of functional programming is that data should be manipulated by functions without maintaining an external state. And there's another thing that really helps in Python is the anonymous functions like Lambda, which we will see in the hands-on session. Now, we have a variety of libraries available in Python, one of which is Pandas. You also have scikit-learn, TensorFlow, and all of those. And Pandas is an ideal tool for data wrangling. Pandas is intended for quick and easy data manipulation tasks such as reading, visualization, aggregation. Now, there are certain tasks that you can perform with Pandas, such as data manipulation tasks, which include indexing, renaming, sorting, merging data frames. You can also modify the definition by updating, adding, and deleting columns. You can also do cleaning and data preparation by imputing missing data or the NaN values. But as I mentioned earlier, data is growing exponentially, and we have billions of rows and columns. Complex operations like merging or grouping of data require parallelization and distributed computing. Now, these operations are very slow and quite expensive and become difficult to handle with the Pandas data frame. And it can often run out of memory if you're doing it on Pandas. That's because Pandas does not support parallelization. So therefore, to build scalable application, we need packages or softwares that can be faster and support parallelization for large data sets. Now, Apache Spark also supports different types of data structures like RDD, which stands for Resilient Distributed Data Sets, data frames, and data sets. So Spark data frames are more suitable for structured data where you have a well-defined schema. You already have your data set into rows and columns, whereas RDDs are used for semi and unstructured data. Now, some of the features for Apache Spark is that it's fast processing. The most important feature of Apache Spark is that has made the big data world choose this technology over others. It is speed. Big data is characterized by volume, variety, velocity, and veracity and value, which need to be processed at higher speed. And Spark contains RDD, which saves time in reading and writing operations. And it allows it to run almost 10 to 100 times faster than Hadoop. Now, the flexibility, Apache Spark supports multiple languages such as Java, Scala, R, or Python. And the biggest feature is in-memory computing. So, which saves us a lot of time. And the reason it's fast is because of in-memory computing. So, Spark stores the data in the RAM of the service, which allows quick access and in turn accelerates the speed of analytics. Real-time processing. So with Spark, it is able to process real-time streaming data, unlike MapReduce, which processes only stored data. Now, with you can get better analytics with Apache Spark in contrast to MapReduce that includes map and reduce functions. Spark includes much more than that. So Apache Spark consists a rich set of SQL queries, machine learning algorithms, and complex analytics. Now, with all these functionalities, analytics can be performed in a better fashion with the help of Spark. So, I hope that is clear. So moving on to some of the use cases for Apache Spark. If you have any questions, you can post them in the chat and we'll do our best to answer them. Also, this session is being recorded, so you can find the recording after the session is completed, and it's being multi-streamed to LinkedIn, Twitch, and YouTube. So if you can watch them in any of the places that you prefer. Now moving on to some of the use cases in Apache Spark. So companies are using Apache Spark in e-commerce industry. One of the common examples I can give is Shopify. Now, Shopify wanted to analyze the kind of products its customers were selling to identify eligible stores with which it can tie up for business partnership. So its data warehousing platform could not address this problem as it always kept running timing out while running data mining queries on millions of records. So Shopify has processed 67 million records in minutes using Apache Spark and has successfully created a list of stores for partnership. Another example is in the healthcare industry, where healthcare providers look for novel ways to enhance the quality of healthcare. Apache Spark is slowly becoming the heartbeat of many healthcare applications. The reason for it is that using the Apache Spark, you can analyze patient records along with past clinical data to identify which patients are likely to face health issues after being discharged from the clinic. Now, this helps hospitals prevent readmittance as they can deploy home healthcare services to the identified patients, and it also saves cost for both the hospital and the patients. Now, one other example of healthcare where Apache Spark is being used is the genomic sequencing. It is used to reduce the time needed to process genome data. Earlier, it took several weeks to organize all the chemical compounds with genes, but now with Apache Spark on Hadoop, it just takes a few hours and you have all the information in just a few hours. So next is okay, one other for healthcare is an application. You might all be very well aware with it if you are into fitness or just in regular diet conscious or whatever. It's MyFitnessPal. So it's one of the largest health and fitness communities. It helps people achieve the healthy lifestyle through better diet and exercise. So MyFitnessPal uses Apache Spark to clean the data entered by users with the end goal of identifying high quality food items. So using Spark, MyFitnessPal has been able to scan through food calorie data of about 80 million users. Earlier, MyFitnessPal used Hadoop to process 2.5 terabytes of data, and that took several days to identify any errors or missing information in it. So it can be done much faster with Apache Spark. The next use case we have is media and entertainment industry. One of the common places where Apache Spark is being used nowadays is gaming industry. So in gaming industry, it's used to identify patterns from the real-time in-game events and respond to them to harvest business opportunities like targeted advertising, auto adjustment of gaming levels based on complexity, player retention, and many more. So another one we have is Netflix. Netflix uses Apache Spark for real-time stream processing to basically provide online recommendation to its customers. Now, streaming devices at Netflix send events which capture all member activities and play a vital role in personalization. It processes about 450 billion events per day, which flow to server-side application and are directed to Apache Kafka. Pinterest is another big name that uses Apache Spark to discover trends in high-value user engagement data so that it can react to developing trends in real time and get an in-depth understanding of user behavior on the website. Now, the other one we have is travel industry. And so travel industry basically, TripAdvisor is a website, is a leading travel website that helps user plan a perfect trip to using Apache Spark to speed up personalized customer recommendations. So these are some of the use cases. The use case that we will be using today is in the finance industry. Now, banks are using the Hadoop alternative, Spark, to access and analyze social media profiles, call recordings, complaint logs, emails, forum discussions, and a lot more to gain insights which can help them make right business decisions for credit risk assessment, targeted advertising, and customer segmentation. So to give you an example, let's say you lost your wallet and your credit card is swiped with $5,000 and the receipt has been signed, but it was not you who swiped the credit card because your wallet was lost. So this might be some kind of credit card fraud. Financial institutions are leveraging big data to find out when and where such frauds are happening so that they can stop them. And they need to resolve any kind of fraudulent charges at the earliest by detecting frauds right from the first minor discrepancy. So they already have models to detect fraudulent transactions, and most of them are deployed in batch environments with the use of Apache Spark on Hadoop. Now, financial institutions can detect fraudulent transactions in real time based on the previous fraud footprints. All the incoming transactions are validated against a database. If there is a match, then a trigger is sent to the call center. Now, the call center person immediately checks with the credit card owner to validate the transaction before any fraud can happen. So this is just an example. To give you all a real life example using this use case is something similar has happened with my dad. His credit cards were charged with a huge amount in the US, and Once we checked with the bank, they sent us a form to fill out and get back to them. So we filled out the form, we gave it back to the bank, and they said they will stop that process as soon as possible. But once we checked the statement of the credit card, uh, my dad was actually never charged for that transaction. That money never left his bank account. So it's really interesting to see how the back end of it works. Now, for the use case today, we will be using a fraud detection CSV file, which Hashim will show you, just to walk you over the architecture flow. So I hope everybody is signed up to Watson Studio, to IBM Cloud, because we will be working with IBM Cloud and creating services on it. So what we will be doing is, after you log in, you will log into Watson Studio and you will create a cloud object storage. You will create a new project. Under that, you will be uploading your CSV files. There is a CSV file for the fraud, and then there's a text format CSV file, which you will understand why there are two. You will be uploading that to the Watson Studio project that you create. You will then create a notebook from the URL that's provided, and then enter the credentials of the database and run your notebook. And Hashim will explain you further on what's happening in the notebook.
All right, thank you, Anam, for the presentation. I hope you all are enjoying the session up till now. The next part of the session is the hands-on one. And before that, I hope you have all signed up for IBM Cloud. My colleague Anam has shared the link to IBM Cloud on the chat. For those of you who have not signed up on IBM Cloud, please do so, because we'll be leveraging the platform for the hands-on session. All right, so let me start sharing my screen. Can everyone see my screen? Anam, can you guys see my screen?
Yes, we can.
Okay, all right. So up till now, we have had a overview of what machine learning is, what data science is, what big data is, and a little bit of introduction to PySpark, which is the framework that we'll be using for the demo today. Before I start the demo, I want to give you all a quick overview of what we will be covering. The basic idea of this hands-on session is to give you a quick overview of PySpark, its benefits, and how it can be used to gather insights from a large data set. So let me start by talking about Spark. My colleague Anam covered it in the introduction, so I'll just go over it really quickly once again. Spark is basically Apache's framework that provides an API to perform massive distributed processing over resilient sets of data. What Spark does is that it provides faster and more general data processing platform, and it allows you to run programs 100 times faster in memory and up to 10 times faster on disk as compared to Hadoop. Right? So it's an amazing framework and it's widely used by data scientists. However, the drawback is that Spark is written in the Scala programming language. So in order to use Python with Spark, what the Apache Spark community did is that it released a tool called PySpark, which allows you to run Spark functionalities in Python. So in a nutshell, that's what PySpark is. It's a framework which allows you to use Spark functionalities when using the Python language. Right. Another important term that will come up quite often in today's session is RDD. So let me mention what RDDs are. RDD stands for Resilient Distributed Datasets. And it is an immutable, fault-tolerant, distributed collection of objects that can be operated on in parallel. In simple terms, you can think of using RDDs as dividing your datasets into multiple chunks and then performing computations on them separately. So as a result of this, you save a lot of time. And apart from saving time, RDDs are also fault tolerant and immutable, all of which pose huge benefits for data scientists. So now that we have an idea of PySpark and we have covered what RDDs are, so with that groundwork, let's get into the demo, right? So our demo what we'll be doing in our demo is we'll be using two very simple data sets, which we load onto the notebook. And once that's done, we'll run some basic computations using PySpark to demonstrate the features and functionalities of the framework. And On a high level, you can think of this demo as broken down into three steps. The first step is the creation of the object storage service on IBM Cloud, where we'll be storing the dataset. The second step will be to create the instance of the Watson Studio service. Watson Studio is IBM's offering for data science and machine learning, and we'll be using Watson Studio to create a notebook and run the PySpark functions. And lastly, we'll be performing the basic computations on our data set, right? So let's get started. We'll start with the first step, which is to create the cloud object storage service. In order to do that, we will go on after logging into IBM Cloud. You can simply search for object storage from the search bar, and there's a typo right there. Let me fix that. Once the name of the service pops up, you can click on it, and you can provide the name for a service. Say getting started with PySpark, and click on create. And what this will do is it will create the object storage service where we will be storing the data sets. So once that's created, we'll move on to the second step, which is the creation of Watson Studio. Again, very simply, we'll search for Watson Studio. And once it comes up, we'll click on Watson Studio.
Hashim, your screen is not very clear. Can you?
Okay. So, okay, do you want me to zoom in a little bit? Let me do that.
Please zoom in.
All right. Is this better?
A little bit, not much, but when you're moving, can you please move your screen a bit slow so that it can adjust?
Okay. All right. Okay, so we'll create the Watson Studio service, similar just like we created the object storage service. We'll click here on create and wait for the service to be provisioned. Let's give it a couple of minutes. For the people who have signed up on IBM Cloud, you will get access to creating all these services for free using the IBM Cloud Lite account. Once the service loads, you have to click on the Get Started button. And let's just wait for the service to load. And once the service is loaded, you'll be able to see all the different options that are available. And what we want to do now is to create a project. So we'll go on this link over here and click on create a project. Once the screen loads up, we'll select the option to create an empty project. So let's just click on this one. And now you'll be able to see that this on the option for the storage, this is the storage service that we created, and it is already integrated in this project. So whatever data we upload, it will directly go to the storage service. So let's create a project. Let's name it Getting Started with PySpark service.
Hashim, please slow down. You're going too fast.
Okay. All right, I'll slow down. Sorry. All right. So once you have selected the name for the project, you need to click on the create button. After clicking on the create button, let's just wait for it to load. And this this process usually takes like about 10 to 15 seconds. So let's just bear with it until it loads. And then the next
Um,
step.
in the meantime, can you show them how to create a project again? If you're having issues with catching up, can you also please see the chat? I am posting the steps in there as well. So
Okay.
just go a little bit slow, Hashan. Thank you.
Okay. All right. I'll just reiterate the steps for those of you who have missed. So up till now, what we have done is we have created a cloud object storage service, and we have created the Watson Studio service. And it's fairly simple how you create those two services. You just go after logging into IBM Cloud, you type cloud object storage in the search bar, and once after typing cloud object storage, uh, actually no, not cloud object storage, object storage. Once you see the results popping up, you can select the result and create the object storage service. And then in a similar manner, you'll do that for the Watson Studio service as well. And as soon as the Watson Studio service is created, you will see the option right on the home page of to create a new project. So you can click on that to create a new project, and once that's done, you'll land on this page right here. Now, the next step is to create the to load the data sets. In order to do that, we'll click on assets, and we'll drag and drop the file, the data sets that we have. Right, so I have the data sets right here. We'll be, as I mentioned, we'll be using two data sets for the purpose of this demo. Fairly simple data sets. Let me quickly open them and show you what is there in these data sets. So the first one is a fraud detection data set where we have a list of users. The data is huge, as you can see, and for someone trying to going through it manually, it would take them a lot of time. But based on these data points that we have, gender, dependence, education, income, and so on, what we are trying to estimate, ascertain is the risk of the person of doing a fraud in terms of the loan that they are acquiring from a bank, right? So this is the data set that we have. As you can see, it's quite clean. In general life, in everyday use, data sets are generally not that clean. You have a lot of missing values, or excuse me, yeah, you have a lot of missing values or values that are wrongly inputted, right? So perhaps you'll have text entered where you should have numbers. So you can use, we have tools such as the data refinery on IBM Cloud. You can use that to clean the data sets. And for people who want to automate the entire pipeline of cleaning the data set, running the necessary algorithms, selecting the algorithms, and for this, especially for people who are starting off with their journey in data science, you can do that through the Auto AI tool, which is also there on IBM Cloud. So look into these two tools. They're really interesting for people starting off with data science, and can be extremely helpful. So this is the data set that we have. We'll be using this one, and the second one that we have is uh, a list of numbers, and the idea that what this data set will be used for is to run the clustering algorithm to show how different types of data points can be clustered into one. Um, uh, so like I said, fairly simple use case. We tried not to complicate it too much. And so yeah, let's get started. We'll select these two data sets and drag and drop them over here, and just wait for them to load. It's just waited a couple of minutes. And yeah, once you have loaded the data sets, you'll be able to see them over here. And once that's done, you can select them and add to project. And since we are using a notebook,
Hashim, can you stop or like when you're clicking, can you please stop for a second so the screen gets clear? Uh, the video quality
sure.
is a bit low.
Okay. All right. So okay, so what I did up till now is I copy pasted the data sets, drag and drop them over here. Once they were loaded, select them and clicked on add to project. And once I click on add to project, I'll see all of these different tools that we can use. We'll be using the notebook, the Jupyter notebook for today's session. So we'll go and select this one. So after clicking on the Jupyter Notebook, we'll get the option of loading uh, the notebook. And the option that we need to select over here is from URL, because we'd be using the URL of the notebook in order to load it. My colleague will share the link to the notebook over here. I have this over here. I have the link to the notebook over here. My colleague will also share that in the chat. So for those of you who are following along, you can use the notebook. You can use this link. The runtime that we'll be using for today's session is Spark and Python. So we'll select this option, Spark 3.0 and Python 3.1. So once that is selected, we need to excuse me. Once we have selected that, we need to select the name for this notebook, and let's just say PySpark demo. And after selecting the name, the runtime, and the notebook URL, we can click on create. Let's just wait for the notebook to load. This process usually takes a while. So what I've done is I've already loaded the notebook in a separate instance of the project. So let me just go to that and continue on the demo over there, because it's just in order to save time, right? So with that, we have loaded the data sets, defined the notebook, and now in order to get started, we need to define a variable called the Spark context. And what this Spark context variable does is that it basically provides you with an entry point into the world of Spark. Uh, you can simply do that through this command, sc.version, and the version of Python, and you'll be able to see the output over here, which means that the Spark context has been initialized. The next step is to import the libraries such as Pandas, the machine learning library that we'll be using, and the k-means algorithm that we'll be using. So we need to import these packages, and that can be done through the set of commands over here. Once you once you are done with these commands, in order to run them, you can simply click on the run button.
Hashim, can you please pause for a minute? Everybody's having an issue. You're going too fast.
Okay, yeah, apologies for that. All right, let me just start from the beginning of from where I loaded onto where I loaded on the datasets to the notebook. So once the datasets have been loaded, we need to define what we call as the Spark context variable. Now, we are using a Jupyter notebook, and the cool thing about the Jupyter notebook is that it allows you to work with allows you to work with code real time. And so all of the lines of code are already written here, so you just need to sort of analyze them and get an understanding of what they're doing and run them, and you'll be able to see the outputs, right? So the first thing that is being done over here is the initialization of the Spark context. And it provides, as I mentioned earlier, it provides us with an entry point into the world of Spark. Once that's done, we import the packages, the important libraries such as Pandas, the machine learning library, and the algorithms through the set of commands over here, right? I hope everyone's following along up till this point. Once you have initialized the Spark context, imported the packages, the next step is to run the functions, right? Now, my colleague in her introduction mentioned the Lambda functions in Python, so I want to very quickly cover what those are. Lambda functions basically are anonymous functions in Python. These functions are not binded to any name during the runtime, and as a result, it's very useful to use these functions when we are running computations on the fly. Right. So in this example, in this demo, basically we'll be using Lambda functions to run methods like map, filter, and so on. Right. So very useful functions that allow us to do computations on the go. These are examples of Lambda functions such as map and filter, and as you can see, once you click on run, the output is generated and show you what's actually happening. Moving on, the next step is to create the RDD. I covered in quite extensively actually what an RDD is. So in this step, we'll be creating an RDD using the parallelize function. Now, the parallelize function is one of the methods to create an RDD. There is a second method of creating an RDD, which is by loading the dataset through an external file, and we look at it in the second half of the hands-on session. But for now, we'll be creating the RDD dataset using the parallelize function, and this is the command that we use to do that. We are creating this. We are storing the value in this numbers.rdd variable, and we are creating it through the parallelize creating it through the parallelize command. We can also perform action, and once we have created the RDD, we can perform transformations and actions on them. And so what are transformations? Well, basically transformations are kind of operations which will transform your RDD data from one form to another. And when you apply this operation on any RDD, you'll get a new one with the transformed data. So operations like map, filter, flat map, they're examples of transformations because they sort of take your data, transform them, and present you with a completely new list of values. An important thing to note here is that although transformations give us new RDD, we can revert back to the old one since RDDs are immutable, right? This is one of the benefits that I mentioned for RDDs, that they're immutable. And again, this is one of the benefits of using RDDs. Right, so we have transformations, and the next thing is actions. So as I mentioned, transformations create RDDs from each other. But when we want to work with the actual data set, it is at that point where an action is performed. And then the values of the actions are then stored to drivers or external storage systems, and these values can be used later on. So transformations so this is basically in a nutshell what transformations and actions on RDDs mean. Right. So moving on, another term that we need to cover over here is the Spark session. What is the Spark session? Well, simply put, in order to use SQL with PySpark, we need to define the Spark session. Once we have created the Spark session, it will allow us to create data frames, data sets, and access Spark SQL services. And again, in this example, we're not writing any code from scratch because it's already been written for us. So we're just initializing it and reading from it, right? So once that's done, we can create a data frame. And a data frame is, well, it's a distributed collection of rows under named columns, and it is very similar to it's exactly the same as a relational database in Excel. Or it's similar to an relational database or an Excel sheet with column headers. So data frames are designed for processing large collections of structured or semi-unstructured data, and are especially useful when running SQL queries, right? So we need to define the data frame from the RDD before we can actually start running our queries and commands on it, right? So, and this is what we do in this part of the section here. We are creating a data frame, and this is called, the data frame is called df names. So if I run it, it gives me the output and shows me what the data frame actually looks like, right? So now this was sort of a laying the groundwork and getting into the now up until this point we had not added any data sets. It was just some generic terminology surrounding PySpark that I was covering. Uh, this is the part where we actually add the data sets, right? So I have already added the data sets over here, but for those of you who will be trying this tutorial from scratch, you will not have the data set already entered over here. I'll show you what it will look like for you guys. It will actually be a blank screen similar to this one. So in order to load the data set over here, we already actually uploaded the data set. So in order to load them onto our notebook, we'll click on this 0100 button. We'll select the data set that we want to upload. For this one, we are using the there's a typo over here. It's actually supposed to be fraud data set. This this is the one that we're going to be using. So click over here and select the Spark session data frame. And once I click on that, the data set has been loaded. And now what we need to do is we need to initialize the correct file name and bucket name. So we'll select that from here. And same thing for the bucket name, we'll copy it and we'll paste it over here, right? And we'll uncomment this. So hashtags are basically used to comment out things, and we'll comment this one. So we uncommented this line and we commented out this line. So, and with that, our data set has been loaded. And the next data set that we are going to load is the 5000 points.txt. And this is the one that we load through the credentials, because this is the data set for which we'll be creating an RDD through an external file. So we'll select the data set and we'll select the credentials over here. Again, we'll uncomment this part. We have the name of the file. We'll copy it from here, paste it over here, and we have the name of the bucket. We'll select over here and paste it over here. Right. So once that's done, with that simple step, we have sort of loaded the data sets. And yeah, this is what it should look like once the data sets have been loaded. So now actually, let me go back to the file that I was running. So once you have loaded the data sets, you will click on the run button over here just to make sure that everything is running correctly and the data sets are working fine. And it should give you the completed message here once it's finished running. You'll do it for both the data sets, and and then once you have loaded the data set, now you need to create a data frame, right? So previously I showed you an example of how to create a generic data frame. Now we are creating a data frame of the data that we actually loaded from the data set, right? So this data frame is named as df-people, and we'll create it through this set of command over here. By clicking run, our data frame will be created. And if we want to see what it looks like, we can run the .show command. And if I click on run over here, I'll be able to see what my data looks like once it's been in the form of a data frame. All right, so the next step is Once we have created the data frames, it will allow us to run some functions and queries. Um, uh, so we can run simple functions like .count, which will give us the total number of entries that are in the data set. Right now, the idea behind all of this is that it is designed to make it easier for us to get insights from data. Right. So simple commands like count and the number of columns, right, they show us what the data actually looks like. So by running the dot columns command, I can see what are the different columns that the data is categorized into. So we have gender, marriage, dependents, and so on. Right, the count function gives returns the total number of values that are in the data set. And the print schema command shows me what kind of values are stored in the data, in all of these values. Right, so instead of actually manually opening the data set, going through it, we can use these commands and sort of get very quickly an insight into what kind of data we are working with. Now we can also filter the data that we want. So if we only want to see certain number of columns, such as education loan amount and loan term, we can do that. We can select just those few rows. And if we don't want to see all the data, because as I showed over here, we have 827 entries. If we don't want to show all of those 827, we can just select over here, the number 20 has been selected, so only the top 20 rows are being shown over here. And I can change this to, let's say, 10, and if I run this, the top 10 rows will be selected. Removing duplicates is again something that we can do through PySpark, and we simply need to run this function which removes the duplicates, and now it gives us the count of the total number of values that are left after removing the duplicates. So all in all, we have 403 unique values in the data set. So again, the idea behind this is to get insights into the data that we have. Right, if we want to know the how many females, the data we have data for how many females. So we can run this command and see we have 607, and we can actually print data for all the females also by running this command. And if we want to see the breakdown of the different genders, we can do that also. So uh, yeah, again, the idea is to through this simple set of commands, you can understand what your data looks like, and and get a better understanding of what kind of insights you can gather from it. You can also change the name of the columns. So we had a column named fraud risk. We changed it to just risk, right? And if I can, yeah, this is the column over here. At first, it was named as fraud risk, but I changed it to risk. So again, one of the functionalities that can be implemented. Now, I mentioned earlier that we can run SQL queries using PySpark, and this is an example of a simple SQL query that we are running using PySpark. So this is, as for the people who have worked with SQL, they will know they'll be very familiar with this syntax. So in SQL, it's very common to run these kind of queries such as select, and then you write the number of columns, and then you select the parameters, and you mention the parameters. And if you want to order the data and so on, you can also select that structure. So you can run these type of queries also using PySpark, and an example of this is mentioned over here. I ran this query, and this was the output that I got. So up until this point, we were sort of trying to gather insights from data which we had stored in an RDD, and this RDD we had created using the parallelized method. Now, I mentioned earlier that the advantage of using RDDs is that it allows us to do computations individually, which saves a lot of time. And I also went over the two ways of creating RDDs. One was through the parallelize function, and the second one is through an external file. So basically, this is the last part of our demo where we will be using this data set, which we loaded through the set of credentials, right? So instead of loading a CSV file, we had a .txt file whose credentials we added over here. Let me scroll up a little bit and show you what we did. We added the credentials to this file, to this external file. And now what we'll do is we'll run the k-means clustering algorithm on this file and show you what the output looks like. So what is the k-means clustering algorithm? Well, the k-means clustering algorithm is an iterative algorithm that tries to partition the data set into predefined non-overlapping clusters. And in this method, each data point belongs to only one group, right? So what the algorithm does is it tries to make the intra-cluster data points as similar as possible, while also making sure that the clusters are as different or as far away from each other as possible, right? So as to give us a better representation of the sample. The way the algorithm works is that it assigns data points to cluster, such as the sum of the squared distance between the data points, and it calculates the variation. The less variation that we have, the better it is. I don't want to get into the details of the k-means algorithm, but it's one of the clustering algorithms that is very commonly used in data science. So, for those of you who want to know more about it, you can go and read up on it. So we loaded this file, and now we will, which, as I showed you earlier, which was a list of different numbers. And the idea is to sort of show the different types of clusterings in the different numbers that were there in the data set. Right. So once we run the clustering algorithm over here, once we do that, we'll get the final output, which looks a little bit like this. Right. So we had all of these numbers which were mapped onto this sort of a graphical in a graphical representation, and it shows you the different clusters that were formed. And as you can see, it provides you with a general overview of what's the spread in your data, right? So these are the center points of the clusters have been marked. So if you have a huge data set and if you want to get a simplified picture of it, this is kind of the way that you could do that, right? So all your data, which was more than 5,000 points, they have been mapped onto this image, and they have, it's mapped onto this sort of a representation, which shows you on through like very easily what kind of spread that you can expect from the data. So that was basically the second part of the demo, where we loaded the data set through the external file and ran the k-means clustering algorithm on it. We can run all the other functions on it as well, which we did in the other part, such as filtering, map, select, removing duplicates, and so on and so forth. So yeah, and I chose the k-means clustering to show you like a different thing that we can do with PySpark, right? So with that, we are at the conclusion of our hands-on session, and now the idea behind this session was just to give you an idea of what you can do with PySpark and how you can use it to get insights and analyze big data, right? So both of the data sets that we used in this demo today were like humongous data sets, and this is nothing as compared to what we face in real life, right? The data sets are even bigger, right? So to get an overview of the data, instead of having to manually go through each and every line and column and row, you can use PySpark to run these simple queries. and get some insight from it. You can, and obviously, if you're creating RDDs, the computations will be much faster. And when you're working with large amounts of data, this is especially useful. So now that brings us to the conclusion of the hands-on part. If you have any questions, I know this material can be uh, a bit challenging for people who are just starting off with it. So if you have any questions, please post them on the chat and we'll try to answer as many questions as possible. And with that, I will leave the floor to my colleague Anam, who will wrap the session up. Thank you all for joining.
Thank you so much, Hashim. So let me just share my screen once again. Hashim, you may stop sharing your screen.
Okay. Nice. Okay.
All right. So thank you everyone for joining us today for our session here. And first of all, I'd just like to clear out a few questions that have been in the question section below. This session is being recorded and it's being multi-streamed, so you can find the recording of this session after we finish on the same link and on YouTube as well. It's being multi-streamed on YouTube, LinkedIn, Twitch, so you can look at that or look wherever it's better for you. And some of the questions that we got, let me just find the questions. Someone had a question saying, what's the difference between volume, I guess, volume and veracity, just to double check. Yeah, variety and veracity. Okay, so variety reflects that data comes from different sources, all right? And so data comes from different sources, machines, people, and processes. It can both be internal and external to organizations. Now, the drivers of variety are your wearable technologies like your watches, social media, mobile technologies, your technologies, and for veracity, it's the quality and the origin of the data where you have to make sure that that you have your facts right and it's accurate. So the attributes include consistency, completeness, integrity, and ambiguity. And so it's with data nowadays, we have to make sure that we have the accurate data and that we have the real data and not wrong data. Now, what is parallelization? So parallelization is basically data is broken into small chunks called RDD. Now, RDD is resilient distributed data sets in Apache Spark, and that is then processed in parallel. So you have a cluster on which you can process your machine learning. You can perform your functions in parallel. Okay, so that's parallelization, and that's one of the reasons why it's so fast. Will PySpark run fast on IBM Cloud notebooks? What is the difference? So PySpark runs faster on IBM Cloud notebook. I mean, PySpark in general runs faster than any of the other systems that we use, such as Pandas or any other libraries that we have because of parallelization as well as in memory. So I think there was another question about is PySpark just fast because of in memory? So that's one of the reasons it's very fast is because of in-memory computing. And you can, what happens with in-memory computing is it doesn't really run the whole program by itself automatically or like at once. So what it does is it stores all the data that is needed for that near the cluster that is being computed. And so whenever it needs more data, it just goes directly and gets the data from there, right? So that's one reason why it's so fast. You can find all the resources for our webinar today in the workshop resources. You will find all the links down below. So you can you have access to that. You have slides, you have the hands-on session, which has the step-by-step guide to how to follow. And one thing that I figured in the in the comment section is while creating notebooks, everybody just left it to the default one, the default environment. That's not right. You have, because we're using Spark, we have to make sure we're using Spark default Spark 3.0 and Python 3.7. Otherwise, when you are loading your data sets, you will have issues. You will not find the PySpark DataFrame session to install. Um, all right, I think that's it for the questions. If there are any, I can answer them later. So let me just move on to the this summary. So we talked about big data, which is the dynamic, large, disparate volumes of data that are being created by people, tools, and machines. There are different drivers for it. The five big V's of big data are velocity, volume, variety, veracity, and value. Just to recap, velocity is the speed at which the data accumulates. Volume is the scale of the data or the increase in the amount of data stored. Variety is the diversity of the data. Structured data fits into rows and columns, whereas unstructured data can be in a predefined, is not organized or predefined. It can be anything like tweets, blog posts, pictures, numbers. And veracity is the quality and the origin of data and its conformity to facts and accuracy, whereas value is our ability and need to turn data into value, right? We then discussed about data science being the process and method for extracting knowledge and insights from large amounts of data, the difference between AI, machine learning, and deep learning. We then talked about supervised and unsupervised learning. Supervised learning is clustering algorithm, which we saw k-means as one of the examples in the use case. And so we have clustering, classification problem, and we have regression in supervised learning. And then for unsupervised learning, we have uh, clustering association and dimension reduction. We then talked about Apache Spark, the five components being Apache Spark Core, Spark SQL, Spark Streaming, MLlib Library, and GraphX. We then saw the difference between Pandas and why Pandas is not reliant with DataFrame. It's because it does not support parallelization. And we then, Apache Spark can also support RDDs, which is resilient distributed data sets, and then can support data frames and data sets. So Spark data frames are more suitable for structured data where you have a well-defined schema, whereas RDDs are used for semi and unstructured data. The features for Apache Spark are fast processing, flexibility, in-memory computing, real-time processing, and better analytics. We then saw some of the use cases of Apache Spark in the industry of e-commerce, healthcare, media, entertainment, and then we had the use case in the finance industry. So this is the survey that you can take and give us your feedback on what you think. What you would like to see in the future. PySpark was one of the topics that was suggested, and we're here with the session. I hope you really liked it, and you can give us your feedback. Now, the Digital Nation platform, some of you might be aware of this platform, but just to recap, this is available for users in Africa and for users in the Middle East using the following, using these links over here. Now, using this platform, you can learn and earn badges. You can innovate. You can build up your profile. There are different courses that you can take and earn badges. So go ahead and sign up for that. We have a digital developer conference for data and AI taking place on June 8th. It's free. You can register for it at the link provided. And there are on-demand replays available. You can also basically learn more about data science, more courses, more hands-on, and you can also earn badges through this. So we have Call for Code happening currently. And Call for Code is basically a call to all the developers and problem solvers to build applications to help the world. It's basically tech for good. And why should you join? It will help you build your skills, skill building, social good, ideas to action, and then you have community of developers that you can communicate with. Now, another reason why you should be joining this is if your solution is if your solution wins, you can win up to $200,000 from global challenge winners. Then there is $10,000 for university challenge winners and 5,000 US dollars for Middle East and Africa region winners. So there is a lot to get from, and you can go ahead and sign up for it. The theme for Code for Code 2021 is climate change. So climate change has three sub-themes, which is clean water and sanitization, zero hunger, responsible production consumption. There was someone in the chat who, in the question and answers, who said they are working with an AI project with water. So I think you can go ahead and sign up to Call for Code and participate. You can build your team, you can work with them, and you never know, you might be one of the winners. So with that, resources and resources for Code for Code, you can go on to the Code for Code main page or the FAQs. You have starter kits, basically the starting point that you can use to to get started. And we have office hours every Monday. I'm sorry, there's a change in the office hours. It's from 6 p.m. to 7 p.m. Dubai time. All right, and you can join this. Once you sign up for Code for Code, you will then be sent an email to join the Slack channel. Once again, I'm sorry, there's a change. The office hours are every Monday from 6 p.m. to 7 p.m. Dubai time. So resources for this session, you can go on to cognitivegraph.ai and learn more about big data fundamentals and Spark fundamentals. You can also earn badges through these courses. And you can also go on to learn.ibm.com to learn more about learn other data science, AI, or other technology. And with that, thank you everyone for joining. I hope you really liked the session, and you can reach out to us on our email. If you need any help, please feel free to reach out. And once again, the session is being recorded. You can find the session. You'll find the recording after the session is completed, and it's being multi-streamed on different channels. You can also find. You will also receive an email with all with the links and everything. So that's it. Thank you, everyone. Naveen, you can find the presentation deck under the workshop resources on the button. If you click that button, it will take you to the GitHub repository. You can find them there. And you will also be receiving an email with all the links. So that's it. Thank you.